Hello everyone, this is Super Seo again. This is the video number 8, the last video of the continuous variable part of this series. So next video will be on the start of the mean and variance, which is 16C or 10C, depending on whether you're looking at extension 1 or advanced HSC mathematics books from Cambridge. All right, so as usual, this is the statement. And the last two questions for us is the challenge / enrichment questions, and these are the two questions under that section. So question 15 and question 16. So it's really like challenging questions. Okay, so see, we now deal with the infinity case. When x goes to infinity, what happens to all of these? So can we still apply the CDF, and can we find the quartiles and stuff like that? So very, very interesting ones. Okay, so here's how we do it. So let's start with question 50. So question 15, the first part, okay, you have to show that it is a PDF. So the little fx is given as 1 on x squared. And we know that x squared, provided that, because sitting in the denominator, provided that x is not 0, then 1 on x squared is always positive, and therefore 1 on x squared is always positive, no matter what x values you've got, as long as it's not 0. And also, if you evaluate it from 0 to infinity, for that to show that is 1, so that's this, and you substitute from 1 to infinity and drop the negative and flip the order of evaluation, then you get that. Now, of course, when you substitute x equals 1 in there, you get 1, but when x goes to infinity, we're not, okay, so I'm technically, quote unquote, I'm substituting infinity into the x, but you can't really do that. So that looks a bit unprofessional. So I'm going to show you the professional way of doing that in a minute. But that's what's happening. 1 on x goes to 0 as x goes to infinity. So that's 1 minus 0, which is 1. So because of those two, we can see that 1 on x squared is actually a PDF. Now, this is the alternative way of doing it, or proper way of doing it, and that is, see, the definite integral from 1 to infinity, that what that means is you take the limit of that. So initially you take you take the integral from 1 to some positive number, let's call that m, okay? And then once you've evaluated this, and then you just take the limit of m going to infinity. So that's basically what it means, okay? So integral from 1 to infinity of whatever the integrand is basically limit of m going to infinity from 1 to m. So that's basically the mathematical definition of this. So if you do that, now that's usual, from the above. So basically, instead of going from there, and there, I'm just taking steps from there to there straight away because I've already done that. So that's this. So m to 1. Notice I've swapped the order. Okay, so that means then 1 take away 1 on m. Now, we know that individually these two has limits as m goes to infinity. Well, the limit of the constant is still that constant, and we know that limit of that exists to be 0. So in that case, we know from year 11 preliminary work that limit of sums or limit of differences is the same as the sum or difference of the limits, if those two individual limits exist, which is the case here. So I can do that. So limit of the constant 1 is still the 1, and limit of that is as m goes to infinity. Obviously that limit is 0. So 1 minus 0 is 1. So this is more professional way of setting up your work. So that's how you do that properly. Okay. All right. Now all the big fx and the rest of the work to be done is this. So that first of all, CDF, that's from 1 to x, and all the x in the little f of x gets replaced by t, and dx by dt, and that's now this 1 on t. From it's negative 1 on t, I know that, but we know from previous calculations that negative 1 on t, 1 on x gets replaced by dropping the negative sign and then swap the order. So then you get that. So that's your CDF. Now, in part C, we also want to know how it behaves, the CDF behaves as x goes to infinity. Okay, now we expect that's going to be 1 because, by definition, cumulative CDF at the end value of the x has to give you 1, okay, by definition. So let's see if that happens. So when you substitute x equal, well, you can't really substitute infinity. So you take the limit of x going to infinity of that big F of x is that, again, limits of individuals exist. So limit of the differences is now the same as the difference of the two limits. So it's going to be 1. And that limit, as x goes to infinity, it's just going to be 0 because the denominator just blows up. Okay, so that's 0. So hence it turns out to be 1. So therefore, this is important as the little fx is a PDF. So we expect, if that's the case, then we expect that to be 1. So which is happening. All right, now the quartiles. So Q2, so you set that 1 on 1 minus 1 on x to be half. That's a simple algebra. So that's 2 is the median. Q1, the lower quartile, set that as quarter. So it's 4 on 3. Q3, that's now this. 1 minus 1 on x equals 3/4. So that x equals 4 to be the upper quartile. All right, so that's question 15. Question 16, exactly the same question, but different frequency function given. So now, if you sketch that, e to the negative x is a nice decay function, okay, with the y-intercept at y equals 1. And clearly, as you can see, for positive x values, it's all positive. Even though it's decreasing, it's still positive. So the first condition is ticked off. And then the second one is that the limit of 0 to infinity, because domain of x has no upper bound at all. So that's like taking the limit from 0 to infinity. Again, the formal definition of that is this. Okay, so working out the primitive of e to the minus x is minus e to the minus x, and it's from 0 to m, and you take the limit as m goes to infinity. But remember, I can drop the negative and then swap the order, so that's that one. And now again, this individual limits exist because e to the 0 is 1 and e to the minus m, and as m goes to infinity is 0, as it turns out. So individual limits exist, therefore it's now the difference of the limits. So that's 1, take away the limit of that is 1 on e to the m. But then again, as m goes to infinity, e to m also goes to infinity. So the whole fraction sort of becomes 0 because the denominator blows up. So that's 1 minus 0, hence that's 1. Okay, so that's nice. So we can conclude that this is now a PDF. Okay, part B, working out the CDF. Same procedure as before in question 15. Just replace all the x by t's in that integrand. So you get this. Again, dropping the negative in front and swap the order, then you get that. So that's your CDF. C, again, the same reasoning as in 15C, meaning as you take x, the limit of x going to infinity, so this second term, you notice it's 1 on e to the, if you like, quote unquote, infinity, and 1 on e to a huge number is just 0. So that again approaches or converges to 1. So therefore, this satisfies the big F of infinity going to 1. And now all the quartiles, so median is 1 minus e to the x is half. So that means 1 on e to the x has to be half, so that x equals ln 2. Okay. Lower quartile is that one. So now 1 on e to the x is 3/4. Okay. So therefore x equals ln 4 on 3. Okay. So if you're still not sure how I got from there to there, this is basically, this step is that, see, then e to the x equals, 1 on e to the x is 3 on 4, so e to the x is 4/3. Hence now using the log definition, x equals log base with e 4/3, which is ln 4 on 3. Similarly, for the 3/4 mark, which is upper quartile, then you get this quarter, so then x equals ln 4. That's your upper quartile. All right, so like I said before, this now concludes our section B, which has been quite a long journey. And from next video on, then we will now have a look at section C, which is mean and variance, which is another interesting stuff using all the calculus. So that about does it for this video, and I look forward to see you guys next series of videos. Thank you.